Hi, I'm Kim Jake Tiani. Welcome to Cooler Facts, the show that's full of surprising facts about the world around us. Science, nature, and technology. The first surprise is the way this show looks. Not me, but the fun animated style you're about to see. Get ready for a fun, fast-paced tour of short video bits. Today, how long is the world's longest tunnel? Why would you need to coat a submarine with rubber? And which precious metal is virtually indestructible? But first, when it comes to space junk, what should we fear most? The size of it or its speed?
Space is one hostile environment. There's extreme temperatures, solar flares, and radiation to worry about. But did you know it's also a dangerous junkyard? Thousands of nuts, bolts, gloves, and other debris from space missions have formed an orbiting garbage dump around Earth. The good news? Most orbital debris is smaller than a tennis ball. The bad news? It's not the size that makes space junk so terrifying. It's the speed. Space junk hurls along at over 35,000 kilometers per hour. That's Mach 28, or 14 times faster than the Concorde at full tilt. Going that fast, the Concorde could jettison you from New York to London in less than 10 minutes. At that speed, a metal chip the size of a grain of rice would do as much damage to a spacecraft as a .22 caliber rifle bullet at point-blank range. Most orbital debris comes from space missions. Ed White wasn't just one of the first to take a spacewalk. He may have been the first to litter up there when he lost a spare glove outside his Gemini 4 craft. Ever since, astronauts have been adding to the mess, and it has a way of coming back to haunt them. A speck of paint made a 4mm crater on the windshield of the Space Shuttle orbiter. NASA technicians regularly replace windows in the crew cabin of the shuttle after hits from fast-flying junk. To protect itself, the shuttle now orbits backwards, which keeps delicate parts like its heat shield guarded against impacts. NASA has had to redirect the flight path of the shuttle over 8 times. That's an average of 1 in every 14 launches. But is space junk a threat to us down here on Earth? Most of it burns up on re-entry. Still, over the last 4 years, 5,400 metric tons of space junk fell to Earth. That's about the size of 450 city buses. Of all the stuff that fell in the last 4 decades, the 2001 plunge of the Mir space station accounts for a quarter of it. Space junk hasn't killed anyone yet, though in 1997, a piece grazed the shoulder of an Oklahoma woman, likely fallout from the launch of the Delta II rocket a year before. The odds of getting hit are about 1 in a trillion. You are way more likely to be hit by lightning. Twice. So how do we prevent a disastrous collision up there? Various agencies track orbital debris. They can launch a rocket at space junk to throw it into a different orbit. Maybe send it into the Earth's atmosphere, where it can burn up out of harm's way. Another solution? Stop littering up there. About 200 objects are added to space every year. In the meantime, space junk isn't the biggest threat to humankind. In fact, when it falls back to Earth, it behaves just like any other meteor, lighting up the sky like a falling star. So, make a wish.
I think my wish is no space junk fall on me. Down here on Earth, building tunnels is one of the star achievements in engineering. Here are some cooler facts you didn't know in the name of digging.
When it comes to digging tunnels, it seems no amount of soil, rock, clay, or mud can stand in our way. Every new tunneling obstacle pushes digging technology. In 400 BC, in the region of Cappadocia in central Turkey, workers used pickaxes to carve away at the volcanic rock, creating a network of underground caves. When foreign invaders attacked, up to 20,000 people would hide there. One of the true marvels of tunneling engineering happened in 1845, while building the first underwater tunnel that connected docks on both sides of London's Thames River. Burrowing through the soft clay and sand seemed impossible. It didn't hold like hard rock. Then engineer Mark Brunel solved that problem. He invented the tunnel shield, a moving 3-tiered scaffolding system. It allowed workers to carve out the soft clay and sand while quickly lining the tunneled area with bricks. This tunnel is still in use today as part of the London Underground's East Line. 150 years later, today's high-tech tools can tunnel through 250 meters of earth in 3 days. That's the length of 8 freight train cars. High in the Swiss Alps, it usually takes 4 hours for a train to twist and turn through the mountains from Zurich to Milan. To cut the trip in half, engineers decided to build a straight tunnel between the two cities. For passenger trains to hit 240 kilometers an hour, the tunnel's design must avoid inclines. Tracks must remain at 500 meters above sea level, the average elevation between both hubs. But in the mountains, 500 meters above sea level translates into 2,300 meters under the peaks. That's more than 3 times the depth of the super skyscraper, the Burj Dubai. When it's complete, the 57-kilometer St. Gothard Tunnel will be the longest in the world. The tunnel boring machine makes it possible. Its 15-meter-wide rotating circular plate with titanium teeth slowly slices rock, carving a 4-story-high cave. At the same time, the machine pumps grout into the cave walls for support before the actual tunnel lining is installed. Boring machines were also used to drill the 50-kilometer tunnel that includes the world's longest underwater tunnel segment at 37.9 kilometers, and the Seikan Tunnel in Japan, the world's longest tunnel overall at a whopping 53 kilometers. That's 2.5 times the entire length of Manhattan. But not all underwater tunnels are constructed by boring holes. They're made by sinking huge prefabricated blocks. In Boston's Big Dig construction project, engineers built huge airtight concrete segments in dry docks, then floated them out into the water, connected the pieces, and then flooded them to sink them into place. Finally, they were pumped dry. The longest of the 6 segments was 133 meters long, 56 meters wide, and 9 meters thick. That's bigger than a 9-meter thick soccer field. And engineers are already imagining a super underwater tunnel. Picture a 5,000-kilometer-long tube that extends under the Atlantic from New York to London, designed for ultra-fast magnetically levitated trains. Who knows? Sometime in the future, there might be a light at the end of that tunnel, too.
A tunnel from New York to London? I don't think I'd enjoy that commute. After the break, it's off to Antarctica to see what surprise is buried deep within the ice. Really cold, cooler facts coming right up. I've lived in India for the last 8 years, and there's so much I love about it. The food, the colors, the energy. And there's one thing I never had to worry about: freezing weather. But even the dreaded cold is full of surprises.
Hate the long winter months? Before you start complaining, remember that severe cold is one of nature's greatest gifts. Thanks to ice, we have relics like Otzi, Europe's oldest mummy. He was discovered in 1991 in a glacier between Austria and Italy. Amazingly, researchers could identify his last meal: unleavened bread, herbs, and meat. They also discovered an arrowhead in his back and ruled his death a murder. Then there's a discovery of the Siberian Ice Maiden. In her frozen grave, her body was adorned in gold and silk, and she was surrounded by a team of horses. She is thought to be 24 centuries old. The coldest natural temperature ever recorded on Earth was in 1982, minus 90 degrees Celsius. That's colder than dry ice. It happened at Russia's Vostok Station in Antarctica. One of the coolest things buried deep in the ice there isn't even frozen. It's Lake Vostok. It's as big as Lake Ontario and plunges 5,000 meters below the ice surface. That's as deep as the CN Tower is tall, times 10. What keeps the waters thawed in the middle of all that ice? One factor is the pressure of the ice sheet above. The other is geothermal heat, or the warmth radiated from deep within the planet, originally generated during its formation. Freezing temperatures are so important to science that many believe they can be used to bring people back from the dead. As a result, there are over 140 human bodies and heads now cryogenically frozen in the US. Cost to freeze the whole body is $150,000. For just the head, it's $80,000. Cryogenics experts are confident that one day they'll have the technology to take the frozen and perfectly preserved cells and tissue and clone a body. The most famous person to be cryogenically preserved is baseball legend Ted Williams.
Play ball!
His head and body are stored in separate vats. Some say his son wanted to preserve the brain as a way of recycling DNA and hopefully recreating the athletic genes of one of the greatest all-time hitters. These days, surgeons can slowly lower a patient's body temperature until they are almost dead in order to operate on them. In 1990, they froze a 24-year-old patient into suspended animation. With his heart rate at 0, they could fix a broken vessel in the middle of his brain. Freezing a patient stops blood flow, giving doctors extra time to repair damaged tissue. So don't hate the cold. It makes life a lot more interesting. It could one day save your life. Perhaps one day bring you back to life.
Okay, so now I know why cold is important, but I'd still take a warm summer day anytime. In fact, I like flying to warm places to recharge the batteries. But some people are afraid of flying. I like what Loudon Wainwright once said, though. I'm not afraid of flying, I'm just afraid of crashing.
At any one time, there are about 3 million people flying around the globe. That's the equivalent of 9,000 jumbo jets full of passengers. With so many lives in the air, it's no surprise that engineers are constantly developing technology to make flying safe. The planes don't collide because every plane flies through the middle of its own private highway, one that's 16 kilometers wide. That's about 100 times wider than the widest highway on the ground. Sometimes, it's a horrific air crash that forces improvements in flying safety. Ever since the 1988 bombing of Pan Am Flight 103 over Lockerbie, Scotland, airports bombard baggage with radiation to detect the presence of nitrogen, the common denominator of explosives. The process is called thermal neutron analysis. Another technology we take for granted today was also the result of a well-known airline disaster. GPS, or Global Positioning Satellite technology, used to be the private domain of the American military. But in 1983, the Soviet Union shot down Korean Airlines Flight 007 because faulty navigation caused the plane to drift off course. GPS could have warned the crew of the error. U.S. President Ronald Reagan ordered the U.S. military to share its technology with the world. In 1988, Aloha Flight 243 made a routine flight that forever changed aviation inspection rules. When the Boeing 737 hit cruising altitude, a section of its roof ruptured. It took 1/10 of a second for the cabin to completely depressurize, and a giant chunk of the plane's fuselage tore away. Miraculously, the 88 passengers survived, and the plane landed safely. Investigators put the blame on the plane's astonishing number of flights, 89,000. The plane withstood 12 takeoffs and landings a day, every day for 19 years. Its lifetime limit was 75,000. As a result, today, for every hour in the air, a plane spends 12 hours with mechanics. Delta Flight 191, on approach to the Dallas-Fort Worth Airport, encountered violent up and down drafts. It caused the plane's speed to drop by 135 kilometers per hour. That sudden change in speed would be the equivalent of driving along the highway and hitting a brick wall. The plane crashed short of the runway. Since then, aircraft mechanisms have changed so pilots can switch to maximum speeds to dodge surprise weather attacks. As a result, wind shear-related accidents have all but vanished. If all this talk about plane crashes gives you the willies, rest assured, flying is safe. If you flew every day of your life, odds are it would take 19,000 years to actually experience a crash. In fact, flying is so safe, by the time you get to the airport, you've already completed the most dangerous part of the journey, the drive.
Now, from planes flying high to submarines on the ocean floor, what if I told you one of the most state-of-the-art subs is made from concrete? Cooler Facts will be right back. Welcome back to Cooler Facts. I'm Kim Jagtiani. If you want to wow or impress your friends with some really cool facts about the sharpest technology around, well, prepare to submerge yourself in the world of submarines.
Submarines are the cutting edge of marine technology. The largest sub ever built was the Soviet Typhoon-class sub. A fleet of 6 were made in 1981, each measuring 175 meters long. That's the length of 7 blue whales. It weighed 33,800 tons, 2.5 times the weight of the Titanic. Its outer hull housed 5 pressure hulls with some definitely unmilitary-like features: a sauna, a swimming pool, a gym, and a smoking lounge. And say goodbye to sunlight. It could stay submerged for 6 months, long enough to sail from the Pacific, under the Arctic ice shield, and then into the North Atlantic. The award for the deepest dive goes to a specially made research submersible that in 1960 descended to the deepest spot of the Pacific Ocean, almost 11 kilometers down. 2 sailors crammed into a 2-meter diameter pressure sphere with steel walls 12 centimeters thick. It had to withstand the deep ocean's crushing pressure, 1.17 tons per square centimeter, the equivalent force of a man balancing 3 Abrams tanks on his head. These days, modern nuclear subs have developed a number of tricks to reduce noise and avoid detection using, of all things, rubber. The hulls won't bounce, but most military subs are coated with rubber to make them less reflective to sonar. The coating consists of sound-absorbing tiles that contain thousands of tiny voids that also reduce the sub's noise trail. It's the same principle used in echo-proofing a music recording studio. To track subs using sound waves, surveillance planes also follow their heat. They use infrared detectors to track the large plumes of heat that fast nuclear-powered submarines leave while rising to the surface. Russian builders have been experimenting with the last material you'd think of for a submarine hull: concrete. Unlike conventional submarines that float until they take on water, the heavy concrete subs need 4 electric turbine pumps to stay afloat. Major navies are concerned. Because concrete becomes stronger under high pressure, these subs could dive below the standard 600 meters crush depth for steel hulls and hide on the rocky sea floor almost undetectable by sonar. Then they could launch torpedoes straight up at ships above. Talk about paving your way to a new world of undersea exploration.
You know, it must have taken some courage to propose the idea of a submarine made of concrete. Coming up right after the break, a metal that is way tougher than concrete and way more rare. More Cooler Facts right around the corner. It's been quite a show. We've traveled as high as space, we've been as low as the seafloor, and even traveled to remote Antarctica. Time to get a little grounded. Or shall I say, get something out of the ground.
Throughout human history, gold has been the ultimate prize for conquering empires, crafty bankers, and even athletes. What's the big draw? For one, gold is really and truly scarce. All the gold that we possess in the world amounts to a mere 140 million tons, barely enough to fill a fenced-in tennis court. The world produces more steel in a single hour. All the gold we dig out of the ground each year could fit in the average-sized living room. Gold is not just rare, it's almost indestructible. We know how iron rusts and copper tarnishes, but gold is one of the most chemically stable elements, which means it resists chemical changes. When exposed to oxygen, it won't oxidize. No rust, tarnish, or other physical degradations. That makes it about the most recycled metal around. More than 85% of all gold ever found is still in use today. Gold mined a century ago could be in your fillings right now. Gold is also extremely malleable. A lump the size of a domino could be flattened into a sheet the size of an Olympic swimming pool. You could roll out that amount into 80 kilometers of very thin wire. That would be 10 times thinner than a human hair. Gold is so rare and precious, people have tried to manufacture their own. The Soviets were somewhat successful, using nuclear reactions to transform lead nuclei into gold. But it took too much energy. Ever wonder where the expression acid test comes from? To test the presence of gold, jewelers used to dip items in nitric acid. Gold doesn't dissolve in nitric acid, hence the term acid test as the gold standard for genuine value. Mining gold these days is not so much about pickaxes as the chemistry of solvents. Gold is found in extremely low concentrations, buried and laced throughout huge chunks of solid iron ore. To get at the gold, the rock is pulverized, then doused with liquid cyanide, which dissolves the gold. Then the cyanide is neutralized, leaving behind pure gold for smelting. Sounds easy enough, but in order to get 1 measly ounce of gold, you need to grind up 30 tons of ore. At some mines, 100 tons of ore must be excavated for a single ounce of the stuff. Australians have developed a more efficient and environmental solution to liquid cyanide and open pit devastation. Researchers down under have discovered microorganisms that eat trace amounts of gold within rocks. They then deposit them into larger nuggets. The idea is to one day harness this fauna for easier extraction from the ground. If they succeed, the world will have a nice, chemical-free method for gold extraction. But it still doesn't solve the problem of the incredible shrinking supply.
Now I know where the expression acid test comes from. And we've come to the end of the show. Don't forget to look for more cooler facts next time. You'll be the life of the party. Thanks for watching. I'm Kim Jake Tiani.